Hey there, welcome to dotnetFlix. You have probably already heard about it. .NET Aspire, the new shiny tool from Microsoft. And Sander Molenkamp is here to tell us all about it, right?
Yeah, definitely. So yeah, .NET Aspire just went GA at Build, right?
hmm
Um, and Aspire is this whole new opinionated stack for building cloud native applications. So why do we even need that? Well, let me ask you, Edwin, what kind of applications are you building these days?
Well, most of the times it's just a lot of microservices based applications, or
Mhm.
at least distributed applications,
Yeah,
mostly incorporating some legacy system, but most of the times it's new software that we build.
right.
And yeah, most of the time in the cloud,
Right.
mostly Azure, AWS, that kind of stuff.
Yeah. So we've both been working in the IT sector for quite a while,
hmm
right? I don't want to focus too much on our age, but you know, so it's quite different from the projects that we started on, right? I
hmm
remember my first project being a desktop application. We were building that with the very first release of .NET Framework, and it was basically just this single executable.
Yeah,
Um,
informs. Been there,
yep,
done that. Yep.
and of course, that's pretty limited, but at the same time, it's also very nice and easy. It's just this one thing that you have to manage. Very easy to debug. You just press F5 in your favorite IDE and you're good to go. But
Yep.
as you said, my projects look the same. A lot of distributed applications. Some are microservices. Some are a bit more like web application or monolithic like, but even then you often have this distinction between at least a backend and a front end, right? That need to communicate over a network.
Yeah, and we see more and more difference between the machines that we built the software on and the machines that it runs on, because that used to be the same back in the days. A Windows server was a Windows server, but now you don't have a cloud locally and all that stuff. So you see kind of a difference there, and
Oh yeah.
that's also, I think, where Aspire is mainly focused on, right?
Yeah, definitely. And you see the same trend with infrastructure being much more diverse and varied. That single server you talked about from yesteryear. We always had a one big SQL Server database.
Yep.
And now many projects do still have that SQL database, but we also use like Mongo or CosmosDB or a
Yep.
Graph database in addition to that, because the application or the large microservices projects has these different kind of workloads that require different kind of data stores.
Yep.
And you see the same thing on the messaging side. If you look at the messaging catalog in Azure, you've got Event Grid, you've got Service Hubs, you've Service Bus, you've got Event Hubs,
Yep.
all different, all serving a slightly different kind of purpose. And pretty often we are building applications that needs more than one of these
Mm.
because of the different workloads, the different use case within the application.
Yeah, exactly.
So that's not always good news because building distributed applications can be quite hard, as you know. So there's a
Mhm.
lot of stuff you need to deal with. So one of the things we need to deal with is service discovery, right? Because if we have a monolithic application and we cut it into pieces, we now have got all these nice microservices. They still need to be able to call each other. So they
Mhm.
need to be able to find each other. They need to have an address. So we need some kind of service discovery mechanism. Um, then you also, when you are running in the cloud, you need a lot of resiliency. Any distributed application makes a lot of network calls. Networks are inherently unreliable. So whenever a transient error occurs, the system returns an error or the network is down for just a millisecond, your application needs to be able to retry to stay up and running. And then you have the all in a loop experience or the local development experience. So back in the day with that single WinForms application, that was really easy. Just press F5, you can run it on your local laptop. But now with these cloud native, these distributed applications, how can I make sure that I can run everything that I need to test my application, to iterate on my code? How can I run that all on my local laptop or machine?
Mhm.
Um, so we need a good experience for that. And then, of course, it's very important for your application to be observable. It's you need to have good insights into how your application is behaving. So that means good logs, metrics, tracing. So especially distributed tracing is really important in distributed um, applications because it shows you how all of the different components of your app work together. And I've met a couple of teams actually that added distributed tracing after they went to production. And they found out that their application was behaving in different ways and patterns that they had initially thought that it was behaving. So that's really important to have that insight. And then finally, once you're ready to deploy to production, you need to have a good process for that as well. And not only for production, but hey, maybe I'm developing a feature and I want to test it in the cloud. I want to do a performance test, or I just want to run it on the real cloud services that's going to run on. So that process should be repeatable, flexible enough to allow you to deploy to those different environments. Now, a lot of this stuff that's already generally available in .NET or in other tools, but it's not always there by default, right? And it can take a new team on a new project that's already busy working out what they're going to build, stuff like that. They also have to figure all this stuff out and add it into a cohesive whole. And that can take a team a lot of time, or maybe some of the features they don't even get to. Maybe observability is still pretty badly implemented a year and a half after we went to production, right? So you want this stuff, you want it to be there from the start. You want it to be as easy as possible for you.
And a question, so that immediately triggers a question like, is it also only for greenfield projects then, or can it also be applied to existing .NET applications?
Yeah, you can definitely apply it to existing applications. So one of the nice things, so you will see it later on. But one of the nice things I think about .NET Aspire is it doesn't really get in the way. It doesn't add a lot of abstraction layers. So it's just it's there on the side to help you out and to get you started. But when you have a project, an existing project, and I did this as a test on one of my existing projects. I just went back into that code and added Aspire after the fact. And some things improved significantly, either by adding functionality like better observability, or by just making things simpler, because Aspire provided defaults that I could then depend on instead of having to write to use code that I wrote myself to set it up.
Yeah, that makes sense. Okay, cool.
So let me just go into what is .NET Aspire for those that may not have been following this project over the last couple of months. So Aspire can really help us set up all those things we just talked about, basically. So the aim is to set you up for success, right? And it's based around these 3 pillars. So first of all, there's orchestration, and that focuses on that inner loop experience. So it really simplifies the management of your app configuration, its dependencies, and it really allows you to have that F5 experience. So I can press F5 and I just have all the infrastructure, all the services that my application is composed of will be started for me, and I can just debug through that whole application. Now, the important thing here is that even though there's like an orchestrator behind the scenes, it's called the developer control plane, that's only useful for production, right? So even though this is called orchestration, we are not talking about orchestration in production where you use a Kubernetes environment or some other orchestrator. So it's only for local development. Then the other pillar are components, which are basically these NuGet packages that Azure or that Aspire provides. And they make it easier to connect to popular services and platforms, like you want to connect to Redis or Kafka or Postgres, and components can help you with that. And they handle a lot of concerns for you, because if you need to connect to, let's say, Redis, you need to figure out, okay, what's the exact format of the connection string? How do I know on what port it is running? How do I set up instrumentation so that I have logs and metrics? How do I incorporate Redis health checks into my health checks? All that stuff is done for you by these components. So it's, of course, then it's very opinionated, but it's really there to help you to set you up for success. And then if you don't like some of those defaults, you can change them afterwards. And then the last one is tooling. So Aspire comes with a lot of project templates. It's a really nice starter app that you can have a look at, which is a really minimal application, but you can see how it all works and how it all connects together. There's some great tooling built into Visual Studio to make it easier to work with Aspire. I'm on a Mac. I used JetBrains Rider, and they've also released a plugin. So that's very nice. Now, for this episode, because we can talk many hours about Aspire, but for this one, I want to focus mainly on the orchestration part, so the local development experience. And I want to take a look at a demo application that uses a lot of the same patterns and technologies that I'm currently using on a real customer project. It's a very simple demo application, but it's the same underlying technology and patterns. And that allows us to see where the .NET Aspire fits really well, but also where it may not fit that well on a real project. And how can we write some code then to make it a better fit and overcome some of those obstacles? So with that, let me jump over into my Rider IDE here. Let me quickly explain to you the projects that I've got set up. So this solution is called Adventure Array. It's basically a application to manage a theme park. But it's very beta at the moment. So it can do only one thing. It can show me the average wait times for some of the rides in the park. And there are a couple of projects here, and it's mainly based around a monolithic design pattern with some components extracted from that monolith to be more scalable. So most of the code is in this application.ui project. So you can think of this as the main project. So it has a couple of APIs, and it also has this client project, which is a Blazor WebAssembly client. So that client UI is hosted by is served by the application UI server project. And then a couple of things are extracted from that. So I have a separate migration service, which simply does the entity framework migration for me, and then it's done. I have a write service, which ingests telemetry coming from the writes, and that telemetry contains the waiting times. So imagine we've got sensors installed in the waiting line so we can track how busy it is. And the write service will receive those messages from a Kafka topic and will save them to the database. Now, because you and I don't have a real theme park, there's also the simulator project, and that will generate some random waiting times for all of the rides. And then I have a domain project with a bit of logic in it, and an infrastructure project with some infrastructure stuff. But I want to focus mainly on these two other projects that you see here. The first one is called AppHost, and the other one is my service defaults project. And these are two special .NET Aspire projects. So the service defaults projects, that contains very opinionated defaults configurations that all your services use. So for example, that sets up OpenTelemetry, it sets up health checks, it sets up, what else? Let's see, resilience for HTTP clients so that you get retries out of the box. It sets up the service discovery mechanism. And what I really like about how they built this is that there's also some commented out code in there. For example, hey, if you want to export to Prometheus, just uncomment these lines, and now you have your Prometheus exporter. So it's very nice, very easy to use. And then we have this AppHost project, which is the one that we are going to focus on now. The AppHost is used to create basically this outline of your application. So it's easiest explained if I just show it to you. So here I have a program CS. And in this program CS, we see there's this builder pattern, which you may also recognize from ASP.NET. Only this time, it's a builder pattern based around a distributed application. So now I can add resources or projects. I can add all kinds of stuff to my distributed application. So I can add like a container or a project or even a executable. So here is where I kind of compose my distributed application out of all these parts. So if we quickly go through this, you see I have a Postgres database. This is a containerized Postgres database, right? So I could have also done builder add container. Where is it? Add container, then specify the image, specify all the port mappings, specify all the environment variables, specify volume mounts if I use those. That's still a lot of work. And you would have to do all those things if you would use like Docker Compose, for example, to set it up. So with Aspire, I can simply use the Postgres component. And that gives me this add Postgres extension method. So now it's really simple. I just say, hey, Aspire, I want to use Postgres. Give it a name. Only in this case, for my project, because it was based on that real-world project, I don't want to use the normal Postgres database. I want to use Postgres with a Citus extension. Now, I don't know if you've heard about Citus, Edwin, but Citus is this extension that you can install on Postgres, and it makes Postgres scale really well horizontally. So you get this concept of a distributed table or a partition table, which means that the table has its data on different nodes, but you can still query it like it's just a single table. And it's very good with time series data. So in this theme park app, we are going to collect a lot of telemetries about the writes, not just wait times, but the end goal is to ingest a lot more kinds of data, and that will all be time series data, and we need to store a lot of it. So I want to use Citus. Now, Citus is still just Postgres, so I can still use the Postgres extension, but with the image extension method, I can say to Aspire, hey, don't use the normal image that you use this image. And then what's also very nice for local development, I can also tell to use pgadmin. So pgadmin is this management tool for Postgres databases. So, and I'll show you in a minute, but it just gives me this web interface that I can use to look at the database, create a database, do all kinds of stuff with it. So that's really useful. Then I also have another piece of infrastructure, Kafka. I use that to send the messages from the simulator and then handle them or consume them in the write servers. And there's also a Aspire component for that. So I can just say, hey, please add Kafka. And then below that, I've got my project. So I have a project for the write service. And you can see that there's this class which has these static properties on it for different kind of projects. And that's generated automatically for you when you add a project reference from the AppHost project to another project. Now, this is also where we start to build connections, right? Because my write service cannot run on its own. It requires a database. It requires Kafka. So I can say, hey, with reference Postgres, with reference Kafka. And what this does is it tells Aspire to take the connection strings of those resources and inject them into the configuration for my .NET project. So that when my .NET project starts, in the connection strings configuration section, there are now connection strings for Postgres and Kafka, and I can use those to connect. Same story for the simulator. Little bit different for the application UI. I still have those references to the infrastructure, but only the Postgres is infrastructure, right? The simulator is not a piece of infrastructure, but it's a different service. So there are no connection strings here. So how will it connect? Well, it will use that service discovery mechanism. So it will inject the address of where the simulator is running. It will inject that into the configuration of the UI servers. And then the UI service can use the service discovery mechanism to to use that, to use that address. And that's really nice because that means that from the application UI, I can just in an HTTP client say, hey, I want to connect to HTTP ://simulator. And that simulator name will be replaced by the actual address. And then the last one is we have that migration service that just migrates my database. And then we can build a builder and we can run it, and it should give me, let's run it. It should give me my distributed application. Now, what will happen in a moment, if everything goes well, is that we'll see the developer dashboard. And that's a very nice dashboard that Aspire provides, and you can also use it on its own. There's a Docker image available. So if you hate everything I'm showing you in this episode, except for the dashboard, you can still use that dashboard on its own. Let me see where my browser window is. Of course, it's on the incorrect screen. But in this dashboard, and I'll zoom in a bit in a minute, you see all your resources. So we have those containers. We have our .NET projects. You can see that the migrations project is already finished because it just had to do one thing, do that migration. And you can see all the endpoints. And these endpoints here for the containers, these are all just randomly chosen ports. You can specify them if you want, but you don't have to. And then you have these endpoints for the .NET services, which use the port numbers that you specify in your launch settings. All right, now I also have in this same developer dashboard, you can also see that we can look at the logging. So here are the logs for Kafka or the logs for one of my servers. You also have structured logging, which is, again, the logging for my servers, but now with added metadata. And of course, we have all those nice things about, or from OpenTelemetry, we have our traces, we have our metrics. So here's, for example, a metric that I'm generating in my simulator, which is just the amount of messages I have produced so far. And in the traces, you can do, if you've used things like Jaeger before or Zipkin, this will be familiar. You can see the traces going over all of your different services, even to the database here. You can see, if I make this a little bit bigger, you can see the queries that are being run. This is really useful. And what I especially like, because this is so optimized for local development, is that these metrics are really refreshed very often, like every second or so. And that's nice because if you use something like Application Insights from your local development, that has a much slower refresh rate, and you are waiting and waiting for that to show up. So it's very good to have this directly working out of the box when you just F5 the project. All right, so let's see what, well, let me show you the app. So let's go to port 5000. So here you can see my very sophisticated app. It doesn't do very much, but you can see that it has some wait times. The simulator rides pretty busy at the moment. So these are generated by the simulator and then consumed by the write service saved into the database. Now, let's talk a little bit more about the database, because if we go back to Rider, let me just stop this, get that out of the way. I've already showed you that I'm using the Postgres component, right? There are basically two types of components. You've got these host components, which I'm using here. So those help set you up with your infrastructure. They spin up your infrastructure. But then you also have these client components that can help you connect to that infrastructure. And in my service defaults project, I've created a little bit of code that all my services can use to create an application DB context, which is my DB context for this app, and can connect to Postgres. So to make that work, I'm using this add mpg SQL DB context call. And that comes from the mpg, I think it was called, let me see, it has a really long name, this package. If we go into dependencies, .NET 8, packages, yeah, it's Aspire NPG SQL Entity Framework Core PostgreSQL. So because I've added that project, or that NuGet package, I can simply say on my host application builder inside my servers, hey, please add MPG SQL DB context. So this is very opinionated because it sets a lot of stuff up for you. It sets it uses connection pooling, it sets up instrumentation, it adds health checks. But this is not always what you want, because this application DB context is registered as a scoped dependency in the dependency injection container.
Yeah.
And well, often that is exactly what you want with application DB context. But let's say that we have a long-running background servers that sometimes needs to get access to application DB context. That background service is a singleton scoped service, most probably. So you cannot inject a scoped DB context. Various ways to deal with that. I could inject like a scope factory, create a scope when I need it, and then resolve the DB context within that scope. That's one way to go. But the other way, which I like more, is to use a IDB context factory, which is just a standard .NET class, which you can use to get access to application or to DB context whenever you need it. But of course, now I cannot use this method anymore. So let's remove this one. And let's first, to create a factory, we need to have a connection string. So how do we get a connection string? Well, that's actually pretty simple, because whether or not I'm using the client component, because I've called this Postgres, and because I'm using this add Postgres method here in my AppHost, and my services have the reference to that, because of all of that, Aspire still injects that connection string into my configuration. So to get a connection string, only thing I have to do is to ask the configuration for the connection string called Postgres. So now I have my connection string. That's already pretty nice, because I didn't need to go into the documentation to see what a connection string for Postgres looks like and all that stuff. And now I can set up that context factory. So the way you do that is there's an extension method called add-db-context-factory. You give the type of your DB context. And then within the options, I can say, hey, use MPG SQL with the connection string. So this works because I have a reference to the MPG SQL NuGet package. And that's also, by the way, really important to note that these clients components, they help set you up your connection, but then they get out of the way, right? I'm using MPG SQL here. I'm not using some MPG SQL abstraction layer that the Aspire team created on top of the actual Postgres SDK. I'm using the Postgres SDK. So now we have a DB context factory, but what did we lose? Well, we just lost all of those opinionated defaults from Aspire, because now we don't have retries anymore. We don't have health checks anymore. I need to set all of that stuff up myself, and I don't want to. Now, fortunately, and this is, I really like this pattern. What they did here is that they also provide a enrich MPG SQL DB context. So this is part of the same component, only now it doesn't matter how you actually create the application DB context. It can still be enriched by Aspire to have those nice things. So if we just jump into this code, so this is the Aspire code, you can see that what it does is it configures your retries and your instrumentation. And that's very nice. So basically, you have these two choice. You have this choice here if you want to do it the simple way and just use this one-liner. Hey, just give me DB context. I don't care. But then if that's not good enough for you and you need to have some custom logic to create your DB context, like I do here with the factory, you can still opt into those opinionated defaults by using the enrich. And this is true not only for the Postgres, but for all of the database components of Aspire.
Yeah.
So I really like that how they set that up. Now let's shift our focus a little bit from the database to messaging, because the other piece of infrastructure I've got here is Kafka. You may have already noticed that I have this extension method called add topic.
Yeah.
So that's actually not part of Aspire. I've created that myself. By default, if you use at Kafka and you start producing messages to a topic, that topic will just be created for you out of the box. So that works. That's really nice. But you cannot specify any other information for that topic. It just uses some defaults. And in my case, I really think it's nice if I could specify the partition count.
Yeah.
So partition count is obviously more important in production, where it has a real impact on scale. But locally, I want to test that. I want to check if my code correctly works with partition count higher than 1. So I decided to create my own extension on this builder to create a extension method that can create as topics for me with a specified partition count. And it's actually really easy to do. I think it's a very nice pattern that I have here. Of course, a builder pattern is always very extensible, and that's also true here in Aspire. So if I go back to my project thingy, Explorer, I don't know how writer calls this, then I've got this extension folder, and in this extension folder, I have a couple of classes. So the first one, where should we start, is Kafka Builder Extensions, right? Because that's the class where I've defined my extension method called addTopic. And you can see that I'm adding this as an extension method to the iResource Builder, but only for iResource Builders that are of type Kafka Server Resource, because I want this to be like an add-on to a Kafka Server Resource. Now, the only thing that I'm currently doing here is I'm adding an annotation to that Kafka resource. So the annotation itself doesn't execute any logic or do anything interesting in particular. The only thing I do with this annotation is I save this little nugget of data, I save it with the Kafka resource. And the data that I want to save is the name of the topic and the partition count. But then at some point during startup, I need to be able to take that information from the builder and actually start creating those topics, right? Yep. I cannot just promise it and not do anything. So the way to do that is you can hook into these lifecycle events. So I've created this Kafka topic creator hook class, which derives from iDistributed application lifecycle hook. And the iDistributed lifecycle hook has 3 options for you to override. So you can hook into the lifecycle before anything starts. You can hook code at the point that the endpoints are allocated. So at this point, everything has a known endpoint and can be addressed. Or I say can be addressed, but you don't know if it's running. You just know that an endpoint has been allocated. But that's important if you want to do something with configuration. And the last one is after resources created. You still don't know if the resource is healthy, if it's even started completely, if it's a container. You just know it's been created. So what I do in my little class is I use that last hook. So after the resources are created, there's a pretty good chance that Kafka is running now. It's about time to start creating those topics. So what I can do, I can go through all of the resources in the app model, because this lifecycle hook gives me the complete app model. I go to all those resources and I look for any Kafka server resources. And when I find one, I'll see if it has any Kafka topic annotations. And if it does, I know that I need to create some topics for it. So I can get the connection string from the Kafka resource. And I basically then create this topic specification object, which is a class in the Confluent Kafka SDK, which you need to create topics. And then I just keep trying to create those topics until we're successful. Because Kafka may still be starting at this point. So it could take, generally it takes about 2 or 3 seconds before this succeeds. And then it's done and I've got my topics. But as you can see, it's very easy to hook into the Aspire model and create extension methods of your own to extend the capabilities of the AppHost, which I really like. Now, the last topic that I want to discuss is cloud resources, because up until now we've talked about containerized resources running locally, but Spire can also help us with cloud resources. So let's say I want to replace this database with a cloud resource. Now in Azure, there's a really nice service called CosmosDB for PostgreSQL. And that offers a fully managed Postgres database, including that Citus extension. So sounds good, right? We can use that in production. But there's not an Aspire component yet for that service. So what to do? A couple of things I can do here. There's this very nice method called add_bicep_template, or add_bicep_template_string if you want to create your bicep dynamically. So you can use either one to just execute some arbitrary bicep script, and then in that bicep script you can set up all your Azure resources, and you're done. You're good to go. Now, of course,
Sander, a question. Yeah? Is that also, I don't know if you're going to talk about that, but is it also possible to output something like the connection string or other things you need to connect to it, and also inject that as environment variables for the configuration, just as you have with the local one? Okay, cool.
Yes, let me show you.
Okay.
This is what I'm going to show you. Basically uses the bicep template underneath. So everything that I'll show you can also do with add_bicep_template. Okay. So what I've done here is I don't want to use add_bicep_template to then have a lot of setup code. I want to use this nice add Azure CosmosDB Postgres method. I don't care if there's not a component, I'll build my own, right? Now, what you also can see, in a minute, we'll dive into this method and see how we've done it. But I first want to talk about the way I've set this up here, because here I'm using the execution context to decide on what to run. And the execution context can be in one of two modes. So you've got run mode, which is, hey, you're running it locally on your machine, or you've got publish mode. And in publish mode, you're basically, Aspire is basically building this manifest file. And in this manifest file, that's a JSON representation of all the resources in your AppHost. And I'll show you in a minute. We can generate one, and you'll see what it looks like. But the gist of it is that other tools, for example, the Azure Developer CLI, can use that manifest file to deploy your application to the cloud. So my manifest file, well, let's just do it now, right? No time like to press it. So let's go to go to the AppHost project, which is in source actually. So on the AppHost project, you can say, hey, build my project, but give it a publisher is manifest parameter, then also an output path, so it knows where to put the manifest. So let's just output to manifest.json. And now this will build my AppHost, and it will generate that manifest JSON file for me. So this should be done in a second. And I already mentioned Azure Developer CLI can use that file to deploy to Azure Container Apps. There's also another open source project that's called Aspire, and you can use Aspire to create Kubernetes manifest files, for example, from your manifest. Or you can do it the hard way and make something yourself. In fact, I've used ChatGPT and to upload the manifest file. And you can then ask GPT for, hey, create Kubernetes manifest files, or hey, create a Terraform file for me. And it does a pretty good job, because that manifest file has a lot of data in it that it can work with. So if we open this, and what you can see here is that we have this JSON file with a single resources object, which contains all the resources in my application. And
Mm.
if you look at Postgres, here it says, hey, there's like an Azure bicep file you need to deploy, and here's the bicep file. And for Kafka, because Kafka is still a container, it says, hey, there's a container you need to deploy, and here's where you can find the image, and here are all the environment variables and the bindings and all that stuff.
Mm.
And what's interesting also here is that, let's, for example, go to the UI. My connection string Postgres in the configuration has a reference to the Postgres resource connection string. So it's not like hard-coded. It still contains dynamic connections between objects. So you can imagine that all kinds of tooling can use this as input data to deploy your application. So let's quickly come back here. So what I want in my case is that, hey, if we are going to production or to the cloud environment, so if we are in publish mode, I want to use the Azure Cosmos DB.
Mm-hmm.
But if I'm just running locally, I want everything to be quick, and I want it to be able to run offline. Just go with the Postgres container that you can spin up using Docker on my local machine.
Mm-hmm.
Now, I could have also chosen to just simply always use the Azure resources, right? So if I just add CosmosDB and don't look at the publish mode, what will happen if you have 5, the developer dashboard will start, and you will see that Aspire will actually deploy a new CosmosDB for you so that you can use it from your local environment. So the first time that's going to take a little bit of time. I think CosmosDB for Postgres can take like 5, maybe if you're unlucky, 10 minutes. But the second time, it will just connect to that same Azure resource, and you're off to the races. So that's up to you how you want to do that. Now, both of these resources will return some connection information that I want to put into my services. So the best thing that I can cast both of these resources to is an iResource builder of type iResource with connection string. And that's enough for my purpose here. So let's see how I've built this extension. It's over here as a CosmosDB extension. Let's start with the extension method again. So here's the extension method at Azure Cosmos DB Postgres. And what I do here, I optionally accept a password parameter. But if I don't give the password, I just create a random password myself, right? As a developer, I don't really need to know the password, because that randomly generated password will end up in a connection string, which is automatically injected into my services. So I don't care. I never see it. And then I create a new Azure Cosmos DB Postgres Server resource, and I add that to the builder. This line is really important. This line is to tell the builder, hey, when you are creating that manifest that I've just shown you, please include this resource, write this to the manifest. If I don't include this line, then in the manifest file, there wouldn't be an Azure Cosmos DB resource, and any tooling that I will use to deploy that would not know that I want a database. So it would just skip it. And then also I tell that resource, hey, there's also this parameter that you need to know about. Now, the resource that I've created here is inherited or is derived from that Azure Bicep resource. And I just pass through the name, and I also tell it which Bicep template file to use. Now, my Bicep file, which I've got right here, this is just a little bit of Bicep to create that database. And it will, as a parameter, take that Cosmos DB password, and it will output a connection string. So we need to get that connection string back from the Bicep operation, from the ARM operation, and return that to the app host, because other services depend on it, as you already asked about a couple of minutes ago. So the way to do that is this resource also implements iResource with connection string. And because it implements that interface, I need to implement this connection string expression. And to do that, I use this other property I've got set up here. It's a Bicep secret output reference. And that will take my connection string output from my bicep file, put it in this property. And then whenever another resource like a service needs access to the connection string, this connection string expression will be called, and that outputs the connection string. So again, just like the Kafka stuff, pretty easy once you get the hang of the concepts that are at play here. So I really like how extensible this is and how you can customize it to your own purposes. There's one thing here where this implementation is a little bit simpler than what the Aspire team is doing, because this is just setting up a single resource and then it's outputting the connection string.
Mhm.
If you run this manually, you will get an error or a warning, I should say, from Bicep telling you that, hey, maybe it's not a good idea to output secrets from a Bicep file, right?
Yeah.
So if you look at the, let's say the Redis component, for example, what that does, or the not the regular Redis, but the Azure Redis, what's it called? Azure Cache
Azure
for
Cache
Redis,
for
something
Redis,
like
yeah.
that. Yeah.
Yeah.
So what they do in that component is they actually also provision a key vault. And that's something that I would do normally when I would write Bicep scripts. You would provision a key vault, take that connection string, put it inside the key vault, and then just output the name of the secret in key vault, something like that, and that's perfectly possible to do that here as well. It's just that I'm lazy and I haven't gotten around to do that here. But yeah, so that's basically all the stuff that I wanted to show you for now. There's a lot more in Aspire. I think we can create a workshop for about a full day.
It's just scratching the surface.
Yeah. I actually really like what I'm seeing so far, because it really sets you up for success. And what I really like is that when you want to make changes, when you want to do things a little bit different, it doesn't get in your way, right? It's not like, oh, I've used .NET Aspire, so now I've got this abstraction layer, now we have to use everything it tells us. You can mix and match. You can add your own stuff to it. You can go into your service defaults. Let's say you don't like how it implemented health checks. Well, it's your code, right? It generates a project for you, but now it's yours to maintain and to change however you like. So that's really powerful. If you plan to use .NET Aspire, the recommendation is to keep up to date, because there will be a lot of releases. That they've gone GA at Build, right? Build was in May. It's kind of an artificial deadline, right? It's a big developer conference, so it's nice to have a GA moment. But they're still hard at work at this. It will only get better in the coming months. I presume they'll keep on a monthly schedule. That's what they did with the previews. And then, of course, we'll have .NET 9 in November at .NET Conf. There'll probably be a .NET Aspire 9 version there as well.
But of course, it's open source, right? So you could contribute and cool.
Yeah. So one of the things that you asked at the beginning was, hey, can you use this on a brownfield project, right? And I think you can pretty well, actually. But the lowest barrier of entry, if you cannot, for whatever reason, cannot use any of their templates, their tools, their components, just looking at the source code and see how they set up OpenTelemetry, all the defaults, the health checks, that's really useful as well, because you can learn a lot from it and then use those good practices in your own code bases.
Yeah, that makes sense. Okay, well, thanks so much for showing us this. As you already mentioned, it's just scratching the surface. So I would suggest that anyone want to start using Aspire, go to the documentation, go to all the resources that's out there. I also think there's lots of videos by Henselman and by Fowler and all these guys building this stuff. So make sure that you keep up to date. Thanks for watching. If you like us and if you like dotnetFlix, please subscribe to our channel, and then we'll see you at the next episode. Thank you and bye-bye.
Bye-bye.